Hello everyone. So today we're gonna discuss internal one paper of data science. It is part 2. We have already seen in part 1 the case study, and now we will jump to a part A section solution, which is a statistical characterization of complaint data. We have a question 1. Give three commonly used statistical measure to characterize dispersion in complaint derived scores. Example: alleged offense severity, evidence strength, harm impact index. Discuss how these measures can be computed efficiently over large complaint repositories. Example: partitioned stores, streaming aggregations, approximate sketches. Now, common dispersion measures. We have range, variance, interquartile range. So range is nothing, just highest score minus lowest. Now, it is a quick indication of total spread. Variance and standard deviation. So variance is average squared deviation from mean, and standard deviation is nothing, just a square root of variance. So it indicates how tightly scores cluster around the mean. We have third, interquartile range. So interquartile range is nothing, just quartile 3 minus quartile 1, and measures a spread of middle 50%, and it is robust against outliers. So we have efficient computation on large complaint stores, partitioned storage, or map reduces time. Each partition computes partial sums, counts mins, maxes, variances combined globally. Streaming aggregations, one pass algorithms, for example, Welford's method for variance, track running mean, track running square deviation, updates in O of 1 memory, approximate sketches, T digest for quartiles, Q1, Q3, and median. Now, hyperlog, count mean sketch for frequencies, fast memory efficient approximations of dispersion measures at scale. We have a question number 2. Sorted evidence strength scores 1 to 100 extracted from complaint text. We have given some sorted values. Now we have question number A. What is the mean score? What is the median? B. What is or are the mode? Comment on modality, uni, bi, or tri model. C. What is the mid-range? D. Estimate quartile 1 and quantile 3. Give the 5-number summary and draw a box plot of their scores, and G is, in this context, how is a quantile plot different from a quantile plot? For example, to check if evidence scores follow a target distribution assumed by the DSS. Answers. So for A, which is mean and median, mean is nothing. We will sum all these numbers. We will get 740, and we will divide it by 26, the total number of data elements we have. So its answer will be 28.46. Median, since our n is even, which is 26, so we will take average of 13th and 14th value. 13th value is 25, 14th is 30, so median will be average of both number, which is 27.5. Now mode plus modality. So frequency highlights, we will see which number occurs more. So it is 35. So we have 35 which occur 4 times. So mode will be 35. Distribution has one strong peak which is 35. So it is unimodal. Now mid-range. Mid-range is nothing, just min and max average, which is 41.5. Now we have to calculate quartile 1 and quartile 3. So for quartile 1 we will see lower half, and for quartile 3 we will see upper half. So these are the elements of a lower half. Median of this will be 7th value, which is 20. So a quartile 1 will be 20. Now for upper half we will see again the 7th value, which is 35. So our quartile 3 will be 35. So quartile 1 is 20 and quartile 3 is 35. Five number summary is nothing, just minimum, quatinval, median, quartile 3, and maximum, which is 13, 20, 27.5, 35, and 70 respectively. Now we have to draw box plot. So we can see that this is 20 and this is 35. So this 20 is what? A quartile 1, and this 35 is what? A quartile 3. And we have median of 27.5. So this is quartile 1, this is quartile 2, and this is median. Now what is a QQ plot? So a quantile plot compares the quantiles of actual evidence strength distribution versus target theoretical distribution assumed by DSS. If point lies on the straight line, distributions match. If curve deviates, then model assumptions about evidence scores may be wrong. We have a third question. Severity index distribution binned from extracted coupling features is shown below. So this is the range we have given and this is the frequency classes. What we have to compute? We have to compute an approximate median severity for the complaint. So for this, our formula will be L plus N by 2 minus CF upon F into H. First of all, we will sum these values, which will be, so our total of frequencies will be 3194. For median, we will have this value and we will get 1597 case. So this will be a median actually. Cumulative frequencies. So 1 to 5 is 200, 6 to 15. Now how to calculate this? We will plus this 200 to this 450. For 6 to 15, we will plus 200 and 450. So we will get 650. Same with 16 to 20. We will plus our 650 with 300. So we will get 950. And for 21 to 50, it will be 2450. So this 21 to 50 will contain a median 191597 case. We have seen the formula. Now L is the lower limit of the median class. So this is a classes, this is the higher value, this is the lower value, and this is the higher value. So our lower limit of median class is what? 21, and CF is cumulative frequency before class, and which is 950 this. And frequency is what? For this case, we have what frequency? Where is our median coming? 21 to 50. So 1500 is our frequency. And H is a class width. So higher limit minus lower limit, we get 29. So this is a class width. We'll put all these values and we will get answer as 33.5. Approx median severity is 34. Now for this, our district intake sample records complaint age and self-assessed incident impact percent for 18 complaints. This is the data, and now we have to compute mean, median, standard deviation for age and impact person. We have to draw box plots for both, and we have to draw a scatter plot and a QQ plot to study the relationship. So mean we know, we just need to add these numbers and divide it by 18. We have 18 as our n. So we'll get our mean as 43.67 for each. Median means we have to take, since it is even, our n is even, so we have to take 9th and 10th values, average, which will be 51, so our median is 51. The standard deviation is also very easy to calculate. It have a formula. This is the formula. We have to do summation of xi minus we have to take a mean value and just square it. So this is the standard deviation formula. What will happen above is we will sum, like first we will keep 23. 23 minus what is our mean? 43.67. So 23 minus 43.67, then plus again 23 minus 43.67 plus 27 minus 43.67 plus we will go to 61. So this is how our standard deviation we will calculate. For impact percent, it is the same. We need to sum all these values we are seeing here, and it is 18. So sum is 480.4, and we have NS 18. So 480.4 upon 18 is 26.69. And again, for median, we will take average of ninth and 10th place. So after sorting, median around 30 to 30.7, and again standard deviation, we can use the same formula to calculate standard deviation. So now we have to make box plots. So we can see here, this will be our quartile 1, this will be our quartile 2, and this will be our median. We can see. Same with this impact person. This is our box plot. And now we can draw a scatter plot plus QQ plot. The scatter plot age versus impact percent. What is the trend here? So light positive relationship, higher age slightly, higher impact percent. Not strictly linear, variance moderate. Now for QQ plot, shows whether impact percent follow a normal distribution, mild deviation at tails, near normal but slightly right skewed. So we have discussed our part A solution. In next video, we will cover part B solution. Thank you.